Hello world, welcome to Ketrix channel. My name is Christian. In today's video, we are going to deploy a serverless API using Serverless Framework. This API will have three main resources: a lambda function written in JavaScript, an API gateway which will receive the user's requests and will trigger the lambda execution, and a DynamoDB database to persist data from our application. But first, we need to explain what is serverless and what is Serverless Framework. What is serverless? Well, serverless, also called serverless computing or functions as a service, is a cloud computing execution model which allows you to run event-triggered code without having to explicitly provision or manage infrastructure. With serverless functions, you pay only for the compute time you consume. There is no charge when your code is not running. In traditional applications, you are required to provision and manage your servers. You pay for those resources, and you are required to manage the scaling up of your servers to handle the traffic. In serverless applications, your cloud provider is responsible for allocating the resources your application needs. You pay only for the amount of resources used to run your application, and the cloud provider is responsible for scaling up to handle the traffic. The main serverless providers today are Microsoft Azure Functions, AWS Lambda, and Google Cloud Functions. In this channel, we are going to focus on AWS Lambda. Let's suppose you are required to deploy a web application which needs to have a front-end UI and a back-end API. With the traditional approach, you would need to first provision your server and the networking resources required to secure your application: your VPC, public and private subnets, security groups, EC2 instances, and also you would need to set up your scaling policies. Second, you would need to install operating system patches, updates, and dependencies in your server. And then you would deploy your code. With the serverless approach, you won't need to worry about the server and the networking resources, since those will be managed by your cloud provider. You will only need to deploy your code, and your cloud provider will bootstrap it in a container and deploy it. If your traffic grows, your cloud provider will automatically scale your application to handle the workload. Let's resume it this way. In a traditional architecture, your cloud provider wants you to provision as many resources as possible, because you will be charged by those resources whether they are being used or not. In a serverless architecture, your cloud provider wants your application to be executed as many times as possible, because you will be charged by the time your code is running and not for the idle time. So what kinds of applications can be serverless? A good example would be a web application backend API. AWS API Gateway offers an integration type called lambda proxy integration, which is a lightweight, flexible API integration type that allows you to integrate an API method or an entire API with a lambda function. Data processing. You can use AWS Lambda to execute code in response to triggers such as changes in data, shifts in system state, or actions by users. Another example is real-time file processing. You can use Amazon S3 to trigger AWS Lambda to process data immediately after an upload. You could also integrate with third-party services and APIs, which offer webhooks integrations to quickly extend your application. And as a last example, you can run cron jobs on AWS Lambda with scheduled events. Now that we know what is serverless, we're going to review what is Serverless Framework. Serverless Framework is a command line tool which allows you to define in a single YAML configuration file your cloud resources in order to deploy serverless applications. According to their GitHub repository, the Serverless Framework builds applications comprised of microservices that run in response to events, auto-scale for you, and only charge you when they run. This lowers the total cost of maintaining your apps, enabling you to build more logic faster. You might be asking yourself why to use Serverless Framework. You could create an AWS Lambda function using AWS Console, but as we have seen in previous videos, it can be difficult, slow, and error-prone, especially if you need to reproduce the exact same outputs in different environments. This is why we promote the use of infrastructure as code. Serverless Framework allows you to create a simple YAML configuration file which will allow you to deploy your functions easily and fast. Since it's based in defining your function resources as code, you can use version control to manage your changes. So how does Serverless Framework work? And how does Serverless Framework relate to what we have seen in previous videos about AWS CloudFormation? Well, under the hood, what Serverless Framework do is that it creates the CloudFormation templates for your application, based in a simplified set of parameters, handling the definition of resources and the relationships between them. Serverless Framework also provides you a command line utility to deploy and remove your application's stack. Thanks to the use of CloudFormation, you can review your stacks in the CloudFormation console. Another great utility of Serverless Framework is that it simplifies the use of functions and variables in the configuration file. First, we are going to create a directory which will contain our files, and we will open that directory with Visual Studio Code. You can use the editor of your choice. Then we are going to run the command sls create -t aws-node.js -n my API. This command will generate two sample files based in the AWS Node.js template. One is the serverless.yaml, which has our resources definition, and the handler.js, which contains the code of our function. The serverless.yaml file has a lot of comments with examples to help you customize your function. You can review them later. We're going to remove most of the comments. After removing them, we will have a file with less than 20 lines. As you can see, we have now a file with three main entries: the service, the provider, and the functions. The service is the project name. The provider is where you define which cloud provider will be used to deploy your functions. Serverless Framework can work with multiple cloud providers. And the functions is where you define your functions and the events that trigger them. You can also define a resource key, which we will see later, where you will define the resources your function use. Now let's take a look at our handler.js file. As you can see, it has an export called hello, which returns a response with the status code 200, and the body, which contains a message and the event argument passed to the function to be executed. This is a very simple code, which doesn't do much. With this basic configuration, we could deploy our function to AWS. Of course, this doesn't make any sense since we haven't defined a trigger which will execute our lambda. But for demo purposes, let's see what is deployed with the configuration as it is. Serverless Framework will use the configuration in your serverless.yaml file to create the necessary resources your application needs to run. In order to deploy your function, it will create two CloudFormation templates, a create template and an update template. The create template will create a S3 bucket to put all the configuration files of the stack generated. After the S3 bucket has been created, Serverless Framework will upload a zip file with your function's code. Then it will deploy the update template, which has the same configuration of the create template, but will add the definition of all the resources defined for your function to work. As you can see, we have our function in our console. It has no triggers, but it already has the code and the log configuration to write to the AWS CloudWatch log. In the next video, we will continue with this demonstration. We will modify our servers.yaml file to include the definition of a DynamoDB database. We will define an IAM role to allow our lambda function to work with that database. And we will define a trigger for our function, which will allow us to execute our function from a custom endpoint. If you have any question, please leave it in the comments section below, and I will try to answer as soon as possible. Once again, thanks for watching, and I hope to see you next time.